from the Mainstream Bio project. Just to let you know, we're recording today's session and it'll be available on the Mainstream Bio YouTube channel for people who want to watch it back. So this is part of the Mainstream Bio webinar series called Revolutionizing Europe's Rural Regions, Circular Bioeconomy Opportunities. It's episode 2, which is focused on small-scale bio-based solutions for primary producers. And the Mainstream Bio project, and you can access the QR code to visit the website if you want more information about the work the project is doing. It's a collaboration between European partners aimed at trying to mainstream small-scale bio-based solutions across Europe. So this is around seeing how we can implement technologies and solutions such as small-scale biorefineries, nutrient recycling solutions, which can take place close to the source of biomass in rural and coastal regions with benefits for rural communities and coastal communities. So just to remind you, we're recording today, and to let you know, this is the second in our episode of our webinar series. We have 6 webinars which are running over a period of 6 weeks. Today we're going to focus on small-scale bio-based solutions for primary producers. And in the weeks coming, we'll be looking at topics such as nutrient recycling solutions, and also looking into the opportunities that these solutions can bring to the regions in terms of environmental sustainability for primary production and business model opportunities, as well as some tools for supporting the participation of primary producers in the bioeconomy. Again, if you want to register for any of these forthcoming webinars, you can do so through the QR code and visiting the Mainstream Bio website. For anyone who wants to ask questions as we go to any of our speakers, you can put them in the chat box. We'll be reviewing them as we go through the webinar, and we'll have an opportunity to ask some of these questions to our speakers at the end of the session. So please put in questions as we go along, and we'll get to them at the end of the session. Just a brief overview of the different speakers we're going to be hearing from today. We're going to have a talk from Berta Nevelink, who is going to talk about some interesting tools that we've developed through the Mainstream Bio project to support the implementation and knowledge around small-scale bio-based solutions. We then have 3 really interesting practical case studies of innovators on the ground who are implementing these types of solutions in different sectors and different feedstocks. So we'll be hearing from Johan Sanders, Adrian Nagy, and Alvin Hunt, who will be presenting case studies, and we'll introduce all of the speakers as we go through the presentation. We'll then have some time for questions at the end. So just as a bit of context for today's webinar and the focus on small-scale bio-based solutions. So the topic has been talked about in recent years at the European Commission level. It was presented as an opportunity for primary producers to become more participate at a higher level within the bio-based value chains as part of the joint European biorefinery vision for 2030 presented by the Star Calibri initiative. It's also being discussed within the updated EU bioeconomy strategy in 2018, where they discussed about small-scale biorefineries being a mechanism to help farmers, foresters, and fishermen to diversify their revenues and better manage market risks while achieving the goals of a circular economy. And even within the BBIJU, the precursor to the Circular Biobased Europe joint undertaking, who conducted a study on the participation of the agriculture sector in the BBIJU, small-scale bio-based technologies have been identified as one of the mechanisms that can really help with producers being able to find a more value-added role within the development of the bioeconomy through potentially producing their own products close to the source of biomass. you see it coming up in funding as well. So there are a number of initiatives that have been funding these types of solutions and projects to try and scale these. The CBEJU, for example, have funded 2 small-scale biorefinery innovation projects focused on the development of these solutions in rural areas. Mainstream Bio is in fact one of 4 sister projects funded under an initiative focused on mainstreaming inclusive small-scale bio-based solutions in European rural areas. And there are various other projects that are being funded, which focus on this multi-actor approach of producers working with technology developers, researchers, to try and scale these or implement these small-scale bio-based solutions. So just to mention some of the drivers for small-scale solutions, some of these could be related to economic, environmental, and social benefits that can come from these. So things like reducing transport costs and emissions. So if you have a smaller localized supply chain, it may require less transport to bring it to a centralized location. So there can be benefits in terms of costs, but also sustainability benefits. It allows for the promotion of nutrient recycling, where you can produce a residue from a process that might have nutrient value, which can be easier transferred back to the farms. These typically will have lower capital expenditure, which can de-risk investment, which can enable ownership by new stakeholders. For example, ownership by communities and cooperatives and individual or a collaboration of farmers, for example. They can enable primary producer diversification, for example, producing pre-treated biomass or intermediate as well as final products close to the source of biomass, and this can add value to primary production. It can ensure a balanced distribution of benefits of bioeconomy locally. So rather than having a very centralized bioeconomy with a few plants owned by larger companies, you can have localized solutions where the revenues and benefits can remain at the local level. And there are also technical advantages in some cases to processing at small scale where we have difficult to mobilize feedstocks, for example, feedstocks which have a high moisture content, or feedstocks which are perishable, which require processing very soon after the harvesting of biomass. So this is a small introduction. We're going to move on to our first speaker. So our first speaker is Bert Enevelink. So Bert has been working at Wageningen Food and Biobased Research in Wageningen University since 2006. He is the task leader of the IEA Bioenergy Task 42 Biorefining in a Circular Economy. And he has a lot of experience through EU projects including Mainstream Bio, as well as projects such as S2 Biome, AgroInlog, BeCool, Magic, and many more. And Bert has been doing some very interesting work within the Mainstream Bio project in developing some useful tools, which Bert will describe now. Over to you, Bert. You're on mute. You're on mute, I think, still, Bert.
Yeah, that was true.
There you go. We can hear you now.
Okay.
Thanks.
Yeah, so sorry. Thanks for the introduction. So I'm working in Wageningen Research in this Mainstream Bio project, and today I will present to you some, let's say, results of the project. So the content of my presentation is actually 2 parts. So I will give you an overview of say the Mainstream Biolog catalogs that we have developed for small-scale bio-based solutions. There are 3 catalogs. I'll go into them in a bit more detail later. So technologies, business models, and social innovations. And these are meant to give you some inspiration and guidance when you try to take a decision. The second part of the presentation is the illustration of a decision support methodology we are developing. First version is on our website, and we'll try to improve it. And at the end project, there will be an update of that methodology. It's intended to match biomass with technology and projects. And on the right-hand side, you can see a list of the technologies and a sort of a output of this decision support methodology. So as I mentioned, there are 3 catalogs, and these are to provide you with inspiration, and certainly not to prescribe exactly what you have to do or take a decision for you. It's that part is up to the user of the system. 3 catalogs. So first of all, small-scale bio-based technologies. Why? Because they are often the center of a new business model for a local bio-based solution. Then there's a catalog on the conceptual framework on business models, and that is actually how do you implement such a technology? So how do you create value, deliver products, etc. And finally, there is a catalog on social innovations, and that is meant to see how can we change, let's say, the behavior of society and promote sustainability. So it's not really immediately technologically related, but what are social implications? So to go to the first catalog, so that's the small-scale bio-based technologies. In total, we had 16 examples of these. They are divided, as you can see, in 3 groups, types of technologies: biochemical technologies, mechanical and thermomechanical, and thermochemical technologies. And you will see later on, for example, on the left-hand side, you can see anaerobic digestion. I have some examples in my slides on that. But we will have a presentation later on the insect-based bioconversion and also on the cultivation of mushrooms. And the Grassa example is a bit, I would say, on extraction and separation processes. So technology are described on a high level, let's say here. What do we describe of such a technology? Actually, 3 parts. So potential feedstock, what goes in this technology, the technology itself, so how is the biomass processed, and the products, what products come out, and then of course some references, so where did we find this information, so that you can get further details there as well if you want to. We had a sort of a 2-step approach. So first we wrote a deliverable, the deliverable 2.1, on small-scale bio-based technologies and also on the other catalogs. And there we put the information. You can recognize here again these headers I just meant: feedstock, technology, products, and references. And then this information was inserted actually in our toolbox that was developed for the Mainstream Bio project. And the next slide I will show you how this more or less looks like. So I'm not going into the toolbox itself because that's Murphy's law, like it will go wrong. So I made some screenshots for you. On the left-hand side, you can see how it looks like. You can see on the top, more or less, these 3 catalogs. So indicated by green is that we're now looking at the technologies catalog. And the next step is that we are looking at the biochemical technologies within that catalog. And then at the bottom, you can see we have several codes. Those are not important, of course, really important for you, but we have a title of the technology and a brief description. And then when you would, in the toolbox, click on this B2, anaerobic digestion, then you would get the screen on the right-hand side where it is further described. And in this case, you can see that it is, let's say, the potential feedstock is described. And if you click the other buttons like technology, product, etc., you will get that information. So this is a way how we present the information in the toolkit. Then going to the second catalog of the business models. There you will find 34 examples. There are more, of course, but this is what we could find in, let's say, in the first round of searching for these business models. these business models, you can already see it here on the slide, is that for each technology, for example, the second one, anaerobic digestion, we've tried to find several business models. And the next slide will show you what information we find. But we try to find several examples, several countries, so that you can get inspiration and, for example, look at an example that is has been realized in your own country. So then you can compare or perhaps contact the people who were working on that business model. On this slide, you can only see a selection, but so as mentioned, in total there are 34 examples. I've made a bit, the red circles indicate some of the ones that we are seeing later on in the case studies that will be presented. So, for example, C52, the oyster growing, the insect-based conversion, etc. Okay, so if we look at the business models, then we see that we store much more information. So category B, C, and D, those were also described on a general level, as I mentioned before. But now you also get some more general information. So who is, for example, the contact person, etc. And there's also a section on what is actually the impact of your of this business model. Environmental, job creation, socioeconomic, etc. So how does this look in, for an example, in the deliverable? So here I have only mentioned for you the section A, the general section for anaerobic digestion, and you can already see here that we also provide some links to say further information, sometimes a contact person. So if you want to really work on a solution in your own region, then you can try to contact, and you like this example. Of course, it will never exactly fit to what your plans are, but you can then contact these people, for example. Let me see. Yeah, so this is how it looks, a part of how it looks in the deliverable, and then again, this was transferred to the toolkit to make it accessible in an easy way. Now you can see that the block business models, the block business models is green here, and you see a list of several business models where you have a title, brief description, a country, and some of the keywords. And here you find an extra facility, say just above the green line with the code, title, etc., that you can also search on certain fields. So if you type in a keyword, then you can then it will only show the ones that refer to your keyword, for example, a type of feedstock or things like that. So if you then, in this case, would have chosen the C22 host example, then on the right-hand side, you again can see what type of information you get in on that example, where in this case we are looking at the technology data, but you could also have seen the feedstock data, impact, etc. So this is how this catalog looks like, and then I'm arriving at the last one, that is the social innovation catalog. There we have 19 examples, and I've just put a circle around the D6 at the bottom. That is a network care farming example. I'll show you that later. First of all, I would like to see, okay, the description of social innovations differs a bit from the first two that I mentioned. So here you have a general description, some of the activities, which actors are involved, and what's the impact on the bioeconomy development, and what's the social impact. So again, how does it look like in the deliverable? Well, like this, some text and some links. On the right-hand side, you can see a screenshot of this example. Care farmers are, it's probably not known in each country, but in the Netherlands, we have this system where, say, mentally handicapped people can work at farm, and then they have sort of a something to do, but useful to do during the day. So that's really a social approach to bio-based solutions. Okay, I'm going to it a bit quicker here because you've seen this already. So again, social innovations, you make a choice and you get the information in the the website in the toolkit. Okay, then for time reason, I now go to the second part of the presentation. So that's the support system we made in the mainstream bio. It should be, and that was already mentioned in the plan, it should be very simple and easy to use. So don't expect difficult or complex calculation methods or whatever. It's a way to structure, let's say, your decision in your head, more or less, let's say. And it is about matching what biomass do I have, what technologies are available, and what products can I then deliver. When using it, you use your own local information. For example, we have done an Irish sport case, and then you talk to the people who want to make some sort of decision, and you get the information. But it can also be combined with a lot of information that has been stored in the mainstream bio toolkit. So the catalogs that I already described, but also there's a bioeconomy repository and some other resources. So you have a lot of background information to support your own decision or to get more information to take the decision. On the right hand side, you can see on the top the mainstream bio homepage, let's say, and then you can see the structure at the bottom of the support system, feedstock, technology, product, and you choose them. Going to the next slide. So this methodology that consists of 2 steps. So first of all, you more or less match these 3. So you choose feedstock, you choose technology, and you choose products in a guided way, let's say. So then you have more or less decided, okay, this is going to be my solution with a match of these 3. And then you make an assessment of this solution. You first describe what's the current situation. So for example, if you have a feedstock and it now remains on the land, that's the current situation. And now you're going to do something new with it. You choose some criteria per impact theme where you want to judge them. You get this supporting information from the toolkit I just described. And then you score on various criteria. And then that is represented in a spider diagram. I have 2 more slides to show you this. So about the matching process. On the right-hand side, the top right, you can see actually how it more or less the logic behind it. So a certain feedstock, for example, type 1, could be treated by several technologies. So you have to make a choice. What technology do I use to convert my feedstock? And then the technology type sometimes can either make product 1 or product 6, for example. So this is a web of possibilities, let's say. That is represented a bit in the bottom because we have sort of made sort of a matching table that if you have in the center, you can see anaerobic digestion. If I have anaerobic digestion, I can use the feedstocks that are on the left-hand side, and I will produce the products that are on the right-hand side. So this is about the matching, and then you do the assessment on various themes, social impact, economic impact, environmental impact, and requirements for implementation. And you can then collect this supporting information I mentioned, and you can see a small screenshot on the top right-hand side that, for example, on creation of new jobs, we have included several reports where you can find more information, or we link you to a website. So you don't have to use this information, but it is available if you want to support your score, because that is then on the bottom hand side. The users, so you yourself say, okay, based on all this information, I think this is a better solution for creating jobs. So I rate it on a 1. You give a rating. 0 means nothing is changed. 2 means it's much better, and -2 means it's the situation gets worse. And then for almost final slide, then you represent this in a spider diagram so that you can see what pops out. The blue circle in this case is the current situation, so all 0, nothing changes. And then the orange line or red line, depending on your screen, is what scores did I give on the various things. So like job creation was a 1 here, well-being of rural communities a 2, etc. Okay, so this is a brief description of the decision support system. If you want more information, I refer you to our website and specifically to the toolkit. And if you want to read it in more detail, then you could look at these 2 deliverables, the 2.1 and 2.4. Okay, so that's my presentation. I understand questions are at the end, so
Yeah.
the floor is yours, James.
Thanks very much, Bert. Really practical tool, I think, for stakeholders and communities. We did have one query on the accessibility of the tool, so we'll just put the link into the toolbox, I think, during the next talk. So so that
and I forgot
actually...
one thing to mention. The tool, if you use a decision support system, you just have to register in the tool. That doesn't mean that you are approved or something, but then your data are stored in your area and nobody else can look at them.
Brilliant. Okay, thanks, Bert. So we'll take questions for Bert at the end of the session, so keep your questions coming. So our next speaker is Professor Johan Sanders. Johan is Emeritus Professor of Biobased Economy at Wageningen University. He previously had research roles in DSM and is a former director of research at a potato starch company. And in 2008, he became one of the co-founders of the company Biosis, who are now a world player in the removal of ammonia during biogas production. And he is also the co-founder of the company Grassa, that he's going to talk about here today, who are very, very well known in terms of grass and green biorefinery. So over to you, Johan.
Yeah, good morning, everybody. Well, my next slide. Yeah, I'm talking about grass biorefinery, and we should know that here in the right part, you can see that grass is a raw material that is very well available in the European Union. We have about 70 million hectares. That is 160 million tons of dry matter of grass per year. And that contains about 30 million tons of protein. And this amount could even be tripled if we would have agronomic improvements. The human consumption as a reference in protein in the European Union per year is about 15 million tons. Grass grows at areas where there is a lot of water, as you can see here. But also it requires a lot of nitrogen, and that is on the right side of this panel. We see that there are several areas in Europe where we have an enormous excess of nitrogen, more than 100 kilograms per hectare per year, and that causes a lot of damage to nature. And the real problem actually is that we have to feed about 8 billion people with at least 60 grams of protein per day. And we should keep within the planetary boundary. And that is the amount of nitrogen, it's about 90 million tons, to keep a resilient planet. But if we would share this amount of nitrogen amongst the 8 billion people, it means that we only get about 12 kilograms of nitrogen per person per year. In the Netherlands, with a very efficient agriculture, we already use twice the amount. And in the European Union, it's even worse. We use 36 kilograms of nitrogen per person per year to make the amount of protein that we require per person. So if this would be the case for all the 8 billion people, we would need 3 planets, and we have to do it with 1. Drastic improvements have to be done. We should use less nitrogen from fertilizers, and we should import a lot less of animal feed products. But the other thing which is often forgotten is that the protein that we can produce in crop growing is not used in an efficient way. Imagine the cow, 75% of the grass protein that is on the field does not end in the milk. So we should improve also the use of the protein that is already produced. And of course, for farmers, we should increase the income. The grass biorefinery, starting from grown grass, the first step is a press. And we separate the fibers and the majority of the resistant protein. And this product is very good for cows. The other fraction is the liquid part, the grass juice, and that contains the protein that is not resistant, but it is very suitable for pigs and poultry. We can isolate it and we can make this protein to replace soy protein or other imported protein. This green protein can be decolored, and then we get a product that is good for human consumption. Apart from the protein from the juice, we can also isolate fructose oligosaccharide, which is a prebiotic sugar, and that helps the immune resistance for small animals. And finally, there is a mineral concentrate containing all the minerals that do not end up in the other products. Here you see a snapshot of the press and the press cake, and this is the dewatering of the protein to make it suitable to store it for pigs and poultry. And in doing so, we can give or we can sell about half of the protein from the grass to pigs and poultry and feed our cows with this press cake, and still we can have the same amount of milk. And that is because normally the cow is not able to use all the protein. I mentioned that already. 25% of the grass cells end unopened in under the tail in manure. And this press can open those cells and therefore can benefit not only from the protein, but of course also from the sugars and the other healthy material that is inside. Upon ensiling, which is done for 75% of the grass in the Netherlands, there are also quite some losses, and we don't have those losses because grass can immediately be processed in this way that I showed. Here you see membranes that are required to make the fructose oligosaccharide prebiotic and to concentrate the minerals. In essence, you see a very similar way of doing the business with the grass biorefinery as compared to the traditional way of using grass, ensiling, and the cows, they make a liquid product that is transported to the milk factory, the dairy factory that makes all kinds of products. Here you see after this pre-treatment with the press cake, which is decentralized, the cows can eat that, and the liquid part of this press goes with trucks to maybe the same factory, and the biorefinery is done in a central way. In so doing, per hectare, there will be a benefit of about 1,600 euros, and I will explain that later. At the moment, we have a pilot factory that processes about 3 tons of fresh grass per hour. Next year, we hope to have a decentralized press, as I showed in the previous slide. And in 3 years from now, we hope to have a large biorefinery that can serve about 1,000 hectares, making about 4,000 tons of protein. And this is profit making, while the others are still not profit making. It has a very good footprint that you can see here. The feedstock, of course, costs our process costs quite some energy, but we make bales as is now done in the traditional way. So this is the traditional way to make the ensiling bales, and we can subtract that. The overall benefit of our process is about 11,000 tons of CO2 per year, and that is mainly caused because we don't use the soybean meal from Brazil or from the United States. Per kilogram of milk, you can see that we reduce the amount of CO2 by about 1 kilogram, starting from traditional way of milk production, which is at about 1.2 kilograms of CO2 in the Netherlands. The economics, we will pay directly upon delivery to the farmer 190 euros per hectare, but there will be an after payment, and that is dividing the profit of the biorefinery, which might be done in a cooperative, and that can be up to, say, 490 euros, and that includes the selling of protein also to the human food application. In the Netherlands, now we do not have anymore the right of derogation to spread 230 kilograms of nitrogen from animal manure per hectare. And we have to obey European legislation, which indicates that we cannot spread more than 170 kilograms of nitrogen from animal sources. But it costs dairy farmers a lot of money to get rid of the manure to crop growers. And we can reduce that because in the manure of the cows that have eaten the unlocked breast cake, there is about 30% less nitrogen and phosphate. There's also quite some lower CO2 emission that I showed on the previous slide. And when we allocate 25% of the amount to farmers, that will generate about 400 euros. So this is the overall benefit to farmers, apart from their milk production that they can have per year. My last slide is the conclusion. Biorefining of grass will increase animal protein production per hectare by about 50%, while the milk quantity and quality stays equal. Biorefining of leaves can substitute all soy and undesired mineral imports into the European Union, and biorefinery will lead to increased rural employability and increased agricultural incomes. I forgot this slide, sorry, where we fed the breast cake to cows, but now only with 13.5% crude protein, including grass breast cake and also the concentrates. And we compare that with a traditional diet of 16% crude protein. And this is done by Wageningen University in the dairy campus. And we get a similar production of milk, say 36 kilograms of milk per day, compared to a negative control, which contains only, say, 14% of crude protein. So this shows that you can reduce the input of protein into cows, keeping the milk quality the same and the quantity, and saving a lot of good precious protein to substitute soy and other proteins from outside. Thank you for your attention.
Thanks, Johan. Fascinating presentation on the work of Grassa. I liked your slide where you show the comparison with the dairy sector, but then being able to bring the benefits even closer to the farm with the grass biorefinery approach. It's very interesting. So if you have questions for Johan, please put them in the chat and we'll get to them towards the end of the session. Our next speaker is Dr. Adrian Nagy. So Adrian is the Managing Director of Pilze Nagy, where she oversees the company's innovation, research and development activities. Over the last 20 years, she's been involved in various international and Hungarian development projects related to bioenergy, biogas, agricultural waste management and mushroom cultivation, and she is also participating in the Margin Up and Farmtopia projects under Horizon Europe, and she serves on as a board member of the National Biomethane Biogas Green Energy Association. Over to you, Adrian. Thank you.
Thank you so much. So thank you so much, James, for this introduction, and good morning for everyone. I have divided my presentation into two parts. So the first part is really about the introduction of our already existing circular bioeconomy model. But in the second part, I just want to show up some new development directions that we are focusing on recently. So probably it's not widely known that mushroom cultivation has many specific benefits. This is a kind of food production relies on the recycling of low-value lignocellulosic side streams primarily derived from agricultural practices or agro-industry. In addition to this, mushroom cultivation can help to intensify the agricultural production in a sustainable way because it doesn't directly need agrarian lands. And also mushrooms can deliver a new perspective on human diet because mushrooms contain high quality protein that can be produced with a greater biological efficiency than animal protein. And they are rich in fiber, minerals, and vitamins, and have low crude fat content. And finally, I have to make a note that we have also weaknesses, like we produce waste. This is the spent mushroom substrate. And in the near future, we have to develop different practical methods for the value-added utilization of these material to get in line with the principles of bioeconomy. Our company, the Pilze Nagy Ltd, is the largest oyster mushroom producer in the Central European region. Started its operation in the early 1990s. And we produce almost 1 million kg of fresh packaged mushrooms every year, creating almost 5,000 tons of spent mushroom substrate annually. This large amount of organic waste waste material caused financial and environmental challenges for us in the past. That problem encouraged us to create this circular mushroom biogas complex system, which is based on mainly the cereal straw. So the whole circle starts here. The straw is partly composed to make a substrate for mushroom production. So this is our substrate. The spun and we have the product here, the fresh mushroom. And the spun mushroom substrate, this is a good feedstock for the anaerobic digestion, which results biogas. Here we can go further in the circle. And we burn this biogas in the engine to generate renewable electric energy and heat. We use the heat for drying leftover mushrooms, and finally, the digest state as the final product of the anaerobic digestion is given back to the agricultural fields as a biofertilizer. And here, how we can close the nutrient loop. This circular bioeconomy model was globally as a first of a kind and has been working successfully for more than 15 years. So in the next slide, I already broke down the material flow into figures. So it means that on an average hectare of arable land, we can produce 3 tons of cereal straw. And on this amount of straw, we can, from this 3 tons of cereal straw, we can produce 9 tons of substrate, adding 6 tons of water. And we can harvest 2 tons of fresh oyster mushrooms. And the leftover, the spent mushroom substrate is about 5 tons from this amount of substrate. And with it, we can generate 1,000 kilowatt hour electricity and 800 kilowatt hour of thermal energy. And finally, the digest state, the amount of the digest state is 29 cubic meter. But in this, even though this mushroom biogas model has been successful over the past decade, we still still faces new challenges from time to time. Currently, there are more competing uses for the same resources for the cereal straw. So due to the energy crisis in 2022, the demand from the bioenergy sector has dramatically increased, which has doubled the price of the wheat straw from 1 year to the next. And furthermore, drier and hotter summers have led to the decrease in yield and available straw in the market. And we have to tell that this has become one of the most significant risks of our sector. This is why we are pleased that the EU funding marginal project has been launched for more than a year. The project is coordinated by the Leibniz Institute of Agricultural Engineering and Bioeconomy and brings together 29 partners from 8 different European countries from across the agriculture and bioeconomy sector. The margin up will develop sustainable and circular value chains to produce bioproducts and biofuels from natural raw materials grown on marginal lands. And the Hungarian use case, we part of it, has 2 main aims in the project. One is diversifying the feedstock base with local and resistant biomass, and the second is the cascaded and added value use of the spent mushroom substrate. So first, I want to focus on growing high-yielding and resistant biomass to get a new type of feedstock for mushroom production. This is the first way how we can expand our existing bioeconomy cycle. So for that reason, we have chosen a marginal land nearby our farm. This is where the Grassa is. This area is typically in the drought zone of Hungary. And our use case has been testing 2 different plants. One is the energy willow and the other is the seed of hermaphrodita. The energy willow is a woody biomass, while the cedar is a perennial herbaceous plant. And the plantation is already a year old. We did the first harvest just a month ago. But this is very early stage for the whole program. So I do not want to conclude the experiment yet, but it's already can be seen is the sida looks more resistant to the drought than the energy willow. On these photos, you can see here's the energy willow from last summer, middle summer, and this is the sida from the same time. And it can be easily recognized that the sida already bringing more biomass than the energy willow in our circumstances. So moving to the problem of the spent mushroom substrate, first I want to identify what is the spent mushroom substrate is about. So certainly we as mushroom practitioners, we completely know what is the SMS. So this is a kind of organic waste material with which we have to do something after our crop cycle has been finished. But in other words, it's a mixture of unutilized substrate materials and mushroom mycelium left after harvesting. But if I want to be more precise, it contains extracellular hydrolytic and oxidative enzymes in a big volume, and the fiber content is already hydrolyzed in a hydrolyzed form with visible holes over the fiber texture, and it contains less lignin and higher content of minerals and a high portion of fungal mycelium. So I believe that the efficiency of the spent mushroom utilization will be the main limiting factor for the growth of the mushroom cultivation sector worldwide. And because by the estimations, 1 kg of mushroom will generate 5 kg of spent mushroom substrate. Or I have to tell you that in our case it is much less. It's only half, and it means that the more mushrooms we produce, the more waste we have to manage in the future. So this is why it's very important to talk about the spent mushroom substrate. So so this is the reason why we keep it important to test new applications, application methods for the valorized utilization of the spent mushroom substrate. In our case, the biogas utilization means the traditional way. Therefore, in the marginal project, we set a goal to develop animal feed from the spent mushroom substrate. This task just started, so I hope that we can present our experimental results very soon. And just to give you a small addition, we use the spent mushroom substrate also for mulching the cedar and the energy willow plantations. So, and from the first summer, we can tell that it works efficiently and keeps the moisture in the soil. So on the right, you can see the spent mushroom substrate, how it looks like, and also how we apply as a mulch on the top of the soil. So, and on my final slide, I really want to just conclude our case study, just give the essence of what is important in it. So our mushroom biogas agri-system is a complex solution for intensifying agricultural production. We produce nutritious and protein-rich food using agricultural residues, which we handle in a circular approach to reduce agricultural waste. And the cascaded way of the agricultural production generates increased value. And to close the nutrient loop, we use the digestate as a biofertilizer. So thank you for your attention.
Thanks, Adrian, and thanks for this case study, which is showing how a farm and food-based industry can become more sustainable, and interesting to see you're still very active in the research side of things to keep improving this as well. So if you have any questions for Adrian, please put them in the chat. Our final case study is going to come from Alvin Hunt, who is the CEO of Hexafly, an Irish company focused on the circular production of protein through insect farming. Alvin has transitioned from the fund management industry to spearheading sustainable solutions in the food supply chain at Hexafly, and his work focuses on leveraging black soldier fly technology to combat the animal feed crisis, blending his expertise in business strategy, sales, and investor relations. Alvin, the floor is yours. Thanks very much.
Thanks, guys. I'll just share this now. Okay, you can see that.
Yep.
Yeah. Hi, guys. My name is Alvin Hunt. I'm CEO of Hexafly. So Hexafly is an insect protein. We take in raw material byproduct from a number of different industries, from the brewing industry, the distilling industry, and the food waste industry. And we use an insect called black soldier fly to bioconvert that into sustainable commodities, oil, protein, and fertilizer. So I'll just move to the next slide. It's a bit slow.
Alvin, can you push the hide button, please?
Oh, yeah. There you go. So what's our vision? Our vision is to bring an insect farming revolution to the world, to end the overexploitation of land and ocean, and ultimately to add to the progress of the human race. And a number of the things that we do at Hexafly line up with the UN Sustainable Development Goals, which are listed there. So this is just an executive summary. This presentation is kind of more geared towards an investor presentation, but I will do my best to try and give a broad overview of what we do, and unfortunately some of the juicier stuff I've had to remove. So Hexafly is an agri-tech biotech company. And we use an insect called black soldier fly to bioconvert these waste streams, turn them into protein oils and fertilizer using a carbon neutral circular economy form of vertical farming. We then sell these commodities to the animal feed, pet food, and fertilizer industries. So why black soldier fly, which is the insect that we use? Well, it has a very fast life cycle of 2.5 weeks versus 3 months for mealworm, which is another insect used in insect farming. It has a 50 to 60% protein content, so it's very high in protein. It has an amino acid profile that's very similar to animal protein, has no known diseases, and can bioconvert most forms of waste. So achievements to date, we've raised 5.5 million in equity fundraising. We have secured 160 million offtake agreement for our for 7 years in advance. We've received another term sheet and for 5 million, and 1 million received from that. We were the first licensed pilot plant to operate in Ireland and the UK. We've got strong IP, and our current pilot plant is operating. This is just background on the team. So there's myself and John. We're both co-founders of Hexafly, and we have Stephen, our COO, and then Abhinav, our Chief Scientific Officer. So just some background on I suppose our diverse team from with different experiences that were brought to the table. Process and products. So to kind of start with an overview of what happens. This is the life cycle of black soldier fly. So it starts off with the reproduction. So the adult flies, they will mate under specific conditions, lighting, moisture, humidity, and they will breed under these conditions. We then use an attractant, which basically draws the insects down to lay their eggs in a particular area, so that we can then harvest those eggs. When those eggs are harvested, we then put them into different size trays and containers, which is called the hatchery stage. And the larvae will then hatch out from the eggs and start to consume the feedstock that we give them. So currently we use a feedstock that is a mixture of brewers and distillers' grains and food waste. And when I say food waste, the food waste only includes fruit and veg waste. For regulatory reasons, you cannot use animal byproduct to feed other animals. So it's only fruit and veg waste, which is turned into a pulp. So the larvae will then eat that food and they will grow bigger. And over that period, then when they get to the maximum size, we then go through the processing. So 95% of the larvae are then moved on to the next stage to be processed into the 3 products. We keep 5% of the adult population of those larvae back, and then they are allowed to mature into pupae, and then that pupae then goes back into the breeding room. So you have a full circular system there. We don't need outside inputs. So the processing of the larvae then, it's generally done through heat treatment, although there are other methods to do that. So then the larvae are then transformed after heat treatment, and they go through an oil press. So it turns the larvae into protein, which is your protein powder, your oil, and then if you want, you can not process the larvae into protein and oil, but you can just keep them as dried larvae and sell them as grubs, which is another product for the pet food sector. So after the larvae have eaten all the feedstock, what they poop out essentially is material called frass. So that's their castings. So that frass acts as a fertilizer, as an organic fertilizer. So that is a 3rd or 4th product. This is a mass balance on a dry matter basis. For 1 mass balance per ton of dry matter input. So for every ton of dry matter that we take in, so that's every ton of feedstock that we take in, we get 63% of that output will be frass, 31% of that will be protein, and 6% of that will be oil. So that generally stays consistent despite kind of minor changes that you make to the feedstock. So what are the products? So the main flagship product is hexameal. So hexameal is the insect protein. So it's a dry protein powder. It's 55 to 60% protein, strong amino acid profile. It's hyperallergenic, so it's suitable for use in the pet food industry for dogs that would be hyperallergenic. It has antimicrobial and gut boosting properties. So there's a whole host of benefits, health benefits to insect protein if you compare it to some of the other kind of substitute ingredients that are used in animal feed, such as soya protein. So from a gut perspective, it improves the immune health of the animal, and as a result, you have better health outcomes at the end. So this product is sold into the pet food industry, the poultry industry, and the swine industry. So insect protein cannot be sold for ruminants. It can be sold into pets, poultry, swine, and into the aquaculture industry. So hexa oil, this is the oil extract that comes from the insects. It's actually bioidentical to coconut oil, so it's the exact same breakdown as coconut oil. The only difference is its color it has kind of an orange hue to it. It's got a very high lauric acid content. It's a high energy food for animals. So this can be used as a supplement, as an oil-based supplement for animals, particularly for poultry. It can also be used in the cosmetics industry, and you can also make candles and waxes and various different things out of it. So hexafras, this is the fertilizer, which is the insect protein castings. So it's a certified organic fertilizer, has a balanced NPK profile of 432. Due to its high chitin content, which acts similarly to a vaccine for plants, bolstering their natural immune system defense. So basically, the fertilizer contains chitin, which is shed from the exoskeleton of the insects, and what that does is it has a positive effect on the immune response of plants to various different pests, such as aphids and things like that. So all of that has been proven in studies. So it's a very good alternative to chemical fertilizers for small scale and medium scale horticulture. And then as I mentioned earlier, if you want to not process into the oil and protein, you can just process the grubs, which is basically your dried and cooked larvae. So this can be sold as bird food. It can be sold for poultry and for other pets as well. Its advantages is it's part of the natural, insects are part of the natural diet of many animals, including birds, reptiles, and fish. And it has a high protein percentage with a strong amino acid profile. It's also high in calcium. That's important for reptiles because they're generally deficient in calcium in their diets. Their bones break pretty easily. This is just an overview of how much we've sold so far in our protein plant. So the environmental impact, this slide kind of takes kind of a snapshot of what does it take to produce 10 kg of protein by land area, greenhouse gas emissions, and water use. So this compares the amount of land area required to produce 10 kg of protein for cattle, poultry, and then insects is compared as well. Apologies, some of the slides haven't formatted correctly, but you can see from the visuals that the impact of insect protein is far less in terms of what is required for its land area, and that is because its vertical farming nature. Its water use as well is low, and its greenhouse gas emissions are low as well. The other factor as well, which is very important, is if you factor in the time it takes to bring a cow or cattle or poultry to maturity, it takes quite a long time. Whereas with insects, their turnaround time from egg all the way to end protein product is 2.5 weeks. So there's a huge saving there and efficiency as a result. Protein production, so kilograms of protein produced per acre of farmland. Again, this just shows how much protein can be produced per acre of farmland. So you're comparing that with soya, legumes, beef, poultry, and black soldier fly. So you can produce much more protein with black soldier fly with a much smaller footprint. This is more geared towards why we're different to other competitors. Basically, our egg outputs are very high as a result of kind of IP development in this. And this means basically that there's less fluctuation in an inconsistency in egg yields, which means ultimately you'll have more stable production line and you have more product to sell at the end of the day. This is background on our current pilot facility. There's a lot of material here, so I'll just try and summarize some of it. But this we with the investment funds that we received a few years ago, we built the first certified pilot facility in Ireland and the UK from a regulatory perspective. So specifically, we built 3 fully insulated, specialized climate-controlled environments for the purpose of breeding, hatching, and growing black soldier fly. We upgraded an empty logistics warehouse by increasing the electrical supply, installing a well system, installing 4 large grain silos to store our feed materials and supply the site with enough fresh water and electricity for our purposes. We purchased numerous pieces of industrial equipment that allowed us to transport and mix feedstock, screen, separate the insects from the frass, also clean, cook, and press the larvae to create 3 products, meal, oil, and frass. We retrofitted a fully automated robot into a tray handling system that was able to keep up with the significant throughputs that the plant required. We produced enough product to generate revenue and secured long-term customers for large quantities. We installed a pelletizing line for the frass, which is the fertilizer, to turn it into the fertilizer pellet, and supplied this to local farmers. It also allowed us to fine-tune our breeding technology, develop and verify a scaled-up process flow, test numerous feedstock sources and mixes, including food waste, brewery waste, grains of all types, and lots of different food industry byproducts. It allowed us to obtain a license as an animal byproduct processor and feed business operator through the Department of Agriculture, Food and the Marine. So during this time, we identified bottlenecks and key scaling factors, and everything on site was done with a large-scale industrial process in mind. Excuse me. Ultimately, the project was a success in that we created a blueprint, large-scale expansion of insect farming, processing, fine-tuned our own in-house technology, and also established key technical partnerships, plus supply and offtake agreements, which would be critical for making a large-scale insect farming project a success in Ireland. It was decided to reduce production in the pilot plant to breeding stock only due to a significant technical issue regarding airflow in the grow out of the buildings that affected the growing stock. We found a technical partner with over 30 years experience in the poultry and pig sector who developed a solution to the insect-wide industry issue, and they have proven their system on numerous sites in Europe. Due to the financial barrier of implementing this system in the current site, it was decided not to invest more in the pilot plant, but to focus on scaling up into a large industrial-sized facility with more lucrative revenues. So this is just kind of it was an overview of what we've done to date and what challenges we had and what we're going to do in the future then comes next. So
we may need to conclude quickly, Alvin, just to get a few
Okay, yes,
questions
no,
in.
no worries. This is just an overview of our kind of roadmap, where we started and where we are going. And then these slides are in relation to our plans for our industrial scale up. So scaling up the insect protein to the next stage. Just the plans, the layouts of what a larger facility looks like, and what kind of volumes that would look like as well. So what the current plant can do, can take in 2,000 tons of food waste. The next site will be able to take in 52,000 tons of food waste and spent grains. And you can see the difference in the inputs and the outputs then at a scale up solution. These are just kind of competitor analysis, different companies that are in the industry, breakdown of the market size as well. Sorry, I'm flicking through these slides. SWOT analysis, partnerships, and yeah, I know anaerobic digestion was mentioned earlier. This is also possible with our industry, so we can use the frass fertilizer that we get as an output. We can bolt on an anaerobic digester to the plant, and the frass actually works brilliantly as a fuel for anaerobic digestion. So we can produce our own electricity and be sustainable from that perspective as well. And there's a breakdown of how the anaerobic digestion works from an electrical perspective. And yeah, this is just some quotes on the insect protein industry. I'll finish with this. We believe that 500,000 metric tons by 2030 will represent a turning point for the insect industry. After reaching 500,000 metric tons, it will be easier for the industry to expand. So that's from a senior analyst at Rabobank. And then from Mads Martensen at Skretting, which is the biggest fish feed producer in Europe. Our goal is that in the future, ingredients used for aquaculture feeds do not compete with food for human consumption. For us, it's important to invest in alternatives like insect meat. So insect protein has a bright future. So thanks, guys. Sorry if I went over time.
No problem. Thanks, Alvin. So just a quick mention. First of all, can I ask all the speakers to open your cameras so we can ask a few questions? If you are watching, if you can fill in this survey to get your perspectives on the webinar using the QR code, we'd really appreciate it. So if I can come, and we probably just have time for one question each. Maybe Johan first. Really fascinating insight into the potential for green biorefineries, which is a lot of potential for Europe. From your perspective with Grassa, what scale do you think is looking most likely to be the optimal scale? And what do you see the potential role for farmers within the development of green biorefineries and the scaling of green biorefineries in Europe?
Yeah, well, I think it should be economic, and it should be also environmental proof. So what we are heading for is a factory that can operate 30 tons per hour in the middle of grassland, which is about 1,000 hectares. That means that the grass doesn't need to be transported more than a few kilometers. And that can be done by agricultural transports and not over the big road. Well, the number of farmers on that 1,000 hectares, that might be 30, 40, because they will not all decide to 100% biorefining of their grass. Maybe it will be 50%, maybe somewhat lower. So we expect about, say, 30 farmers. They could be in a small cooperative. Then each of them do not need to bring in a lot of money, and they will have an improved earning. And certainly for the first few of these types, it can make a good start. In Denmark, it is a different model, but there is a factory that operates about at the same size, but they collect grass from longer distances, and they use the press cake for biogas, because that is advantageous in Denmark. And I don't think it is wise, because of the planetary boundary, to do that. Good protein should be used as feed or as food, and not for energy.
Okay, thanks, Johan. Adrian, if I can come to you, just as your case study presents in terms of Pilze Nagy, you've invested a lot of focus in making the company more sustainable over time and a lot of commitment. I'm just wondering two things. Are there challenges you faced along the way in terms of doing that as a company? And also, if there is any advice you would give other companies who are planning in a similar kind of food, agri, farm-based industry, if they were considering doing some of the same steps, if there were any advice you could provide to them.
So I have to tell you that the main challenge was the innovation itself. So the nature of the innovation is that we have to accept the failure within. So and it's normally one from a 10, from idea from a 10 can be successful. So and then other 9 we just spend money on. So this is why the SME sector is not really active in innovation. So my feeling is, and also my experience is that this is the main barrier in between the innovation and the SME sector. So this is why it's important when you can be involved in European fund project, and then that allow you to go through these kind of problems. And I have to tell you, this is the main challenge, the innovation and the nature of the innovation. And what I can advise to the primary producer sector is just the networking, and not just locally. The local network is very important. This is the most important one because you can rely on your neighbors on a daily basis. But the international networking, which can enter how you can enter to the life of the innovation.
Okay, thanks, Adrian. Alvin, I have a question if you're still with us for you.
Yep.
Okay,
Sorry.
great. So I'm just wondering from your perspective with Hexafly, how you feel that a novel protein approach like Hexafly have developed could interact with traditional agricultural production as well as future bioeconomy development.
Yeah, so I think insect protein can complement the existing agricultural industry. So our main focus and the main focus of the insect protein industry is to produce sustainable protein that can replace unsustainable protein such as fish meal and soya protein, and to be able to produce the protein locally and supply it to the animal feed industry locally. So there's a reduction in the need to transport protein across the world from Brazil, etc., into Europe to then be fed to animals. And then from a second perspective, it's complementing the agricultural industry by providing a better quality protein, something that's more suited to the animal's diet and has better outcomes. So in that sense, it's giving the animals better food, and it's also more sustainable, and it's being produced locally. So that I would say it's complementing in that sense. And then in terms of the wider bioeconomy development, I think there's as we're learning about today, there's the bioeconomy is developing in so many different streams, and there's so many different innovations that are some are coming on stream quicker more than others. But I think insect protein fits into that and has been growing over the last couple of years. There's been very large investments that have been made into insect protein in Europe specifically and in North America, and I think it's all moving in the right direction in terms of the circular economy from that perspective.
Great, thanks, Alvin. And we have a question in the chat, Bert. I might see if we can get you to answer this one.
Yeah, I was already thinking about an answer for that question, and I indeed think you should perhaps take a look at this social innovation catalog, because there are some solutions that really refer to this. So it was also mentioned a bit already by Johan. You can start, for example, a cooperative. So if one farmer cannot manage, you should do that together. Okay, in the Netherlands we have a lot of experience with cooperatives, but in some other European countries that might be an innovation in this case, but it's also things like involve, for example, the customers. Some of the social innovations aim at customers who pre-buy the final product, for example, and that way you can create your own market, local, regional market already, and you have some sort of stability in your solution. So I indeed think it also relates to social innovations when you want to implement these solutions. I don't know if this completely answers the question, but...
Thanks very much, Bert. I'm conscious of time, so we'll bring this to a conclusion. So just to mention, next week we're going to have our third webinar, which is going to focus on nutrient recycling solutions for primary producers. We'll send you this via email, so you're aware of it after the webinar. So if you can join us, that would be great. And just to leave you, if you do have time to complete the survey to let us know what you thought about today's webinar, it would be great. And finally, just to thank all of our speakers. Thanks to you for attending, but thanks to all of our speakers as well. Bert for presenting the Mainstream Bio Toolbox, and also to Johan, Adrian, and Alvin for presenting some really interesting and diverse case studies of the practical implementation of small-scale bio-based solutions. So thanks very much and have a great week ahead, and bye-bye.
Bye-bye.